Hey guys, welcome to the next installment of How to iDefine. Today we're going to look at the fundamentals of iDefine. And these are the things that you need to know to get a grasp of how iDefine works as a tool and how best to utilize it. So the first question that needs answering is, what is iDefine? Well, iDefine is a tool that allows you to simulate your system functionality, device logic, compile it together, create documentation around that, and develop a working practice within the tool, such as workflows, requirements, and follow the whole V life cycle through from start to finish. The most substantial thing about this tool that I found when I was using it to develop my systems was the things you do as an engineer to create the systems that you've been tasked to create should be regularly available and compilable into documentation. Most of the time we spend our lives creating our designs and then documenting them afterwards, or documenting something as a baseline and then trying to put that into something functional and finding out that it was wrong in the first place. What this allows you to do, this tool, is create or model your system functionality so you've got a high chance of success when it comes to implementing your design. All the while, in the background, it's compiling all that information ready for when you just want to press a button and generate the documentation at that moment in time, exactly as it is at that iteration. That's the power that this tool provides, in my opinion. So bringing it back to the tool, the database is where everything lives. It's where the functions live, where the test cases live, where typicals, modules, requirements, you've got simulations, you've got documents, reports, history, viewers, everything you can think of is in the database. And this is what makes iDefine powerful, because you can query every single thing that you've done in the tool. You can do so many things and automate so many things that you just couldn't do before. Creating documents from a template which just grabs all the information that you need about a design and creating a design document. This type of thing can happen at the push of a button. Now let's get into how iDefine is structured. So in iDefine there's something called client I/O, and you can imagine client I/O as your signal list or device list, however you want to imagine it, but you can store individual signals, give them their parameters. If it's, for example, a analog signal which has a range that it operates in, so it's measuring something in certain units and you want to add a range to it, then you can create a column which has a max and a min, and it will operate in those ranges, and so you can specify the parameters of signals. What you can also do is store items in there, and items will have signals underneath them, right? So, and the way you do that is you use typicals to create items or devices or whatever you want to call it, functionality that has inputs and outputs, and those inputs and outputs are stored under that item. And now we've got all our signals and items in our client I/O. We want to bring them all together and surround them with some high-level logic to control each of these items. And that's where modules come in. Modules take the typicals, the function blocks, and you can put your own high-level logic in there as well. And you can also bring multiple modules together. You can almost imagine the typicals and functions as the items and potentially devices on, say, a plant, and the modules as the system itself. And you can have a system functionality in a module. It doesn't have to be like that, but it's a good way to visualize it. Usually typicals and functions are referenced by modules, and those modules then go into what we call the output configuration. The output configuration is basically the code that comes out of the project. So imagine if you're compiling all of your software together to create system functionality, that is your output configuration. And that output configuration is used for simulation, it's used for generating code through the drivers that Trinity provide, and they can be put straight onto PLCs, or you could just use this model as a reference to compare your actual code to, if you really want to do it that way. So the one thing I'd like you to take away from this is that iDefine runs off a database. So imagine you're writing to cells in a database and then reading from those cells to get that information. That is basically your input and output. You input to the database and you output from the database. And that's how the modules work. That's how, when you instantiate the function blocks with input and output tags in modules, that's how that works as well. It's writing to the database and reading back from it. And that's the gist and the fundamentals. So that's it for this video, guys. I hope that made sense. If it didn't make sense or you've got any questions, please leave me a comment and I'll get back to you. I read all of the comments, okay? Don't forget to like and subscribe, and I will see you in the next one.